Over the last 2 weeks, you've seen several ways to express functions, to compose them, to use them in your program. In this session, we are going to review the language constructs that you have seen so far in one syntax summary that you can use as a reference. In fact, there's a standard way to describe elements like that with a grammar, and one of the most commonly used notations for such a grammar is called extended Bacchus-Naur form. So in that extended Bacchus-Naur form, a vertical bar would denote an alternative, brackets would denote an optional element, 0 or 1 occurrences of an element, and braces would denote a repetition, 0 or more occurrences of an element. Let's start with types. We've seen two forms of types, so we would have a bar here. A type in our language is a simple type or a function type. A simple type so far is just an identifier. And a function type always contains an arrow, and on the left-hand side of the arrow could be either a simple type or a set of types in parentheses. Another way to put it would be the following. A type can be either a numeric type, so we've seen int and double, but there's also byte, short, character, long, and float. That's the same as the primitive types in Java. Or it could be the Boolean types, that has values true and false, as we have seen. Or it could be the string type. Or it could be a function type, such as int to int or pair of ints to ints. Later, we're going to see more form of types than these. Let's look at expressions. So here you see the complete syntax of expressions. I'm not going to go into detail, but it's there for you as a reference. Let's look instead at categories of expressions and some examples. So an expression can be an identifier, such as x or is good enough, or it can be a literal, such as 0 or 1.0 or ABC in quotes, or it can be a function application, such as square root of x, or an operator application, such as y plus x, or a selection. We've seen math.apps that selected the apps method from the math module, or a conditional expression, such as if x less than 0 minus x else x, or it can be a block, like the one that you see here in braces, or finally an anonymous function, such as x arrow x plus 1. The last syntactic category are definitions. We have seen so far function definitions and value definitions. Function definitions start with a def, followed by an identifier, followed by 0 or more parameter lists, followed by an optional result type, followed by an equal sign, and finally an expression. Value definitions are simpler. They consist of val, then an ident, then an optional type, then equals, then expressions. Parameters can be by name or by value. So a parameter is an identifier, then a colon, and then comes a type. But you can prefix the type with the arrow, and we've seen that means a call by name parameter. So that's all the syntax that we've seen so far, that we've needed so far in our examples. We will add more elements as we need them over the coming weeks. So those are all the language elements that we have used so far. You will notice that they're all related to functions and that we have spoken very, very little about data. We had only some primitive data types like doubles or ints or booleans. This is going to change next week, where we are going to study new ways to introduce data that are centered around classes and objects.